Hi everyone, welcome to today's tutorial. So in this tutorial, we're going to be discussing how to find the identity element and the inverse of any binary operation. So if you have not yet subscribed to the channel, make sure that you do so by clicking the subscription button. All right, so this is just a continuation of what we started during the last lecture that we had, last lesson that we had. Okay, so to find the identity element or the inverse of any given binary operation, you first have to understand that if you multiply, or not really multiplying, but you find the operation between, okay, let me just go back. So if you find an operation between the identity element and the original element, the answer is always supposed to be equal to that element. What do I mean? If you find, let's say if you have A, then if you find the operation between A and its identity element, the answer is always supposed to be A. Even the other way is also the same. If we say E, which is the identity element, you find the operation between that and that, the answer is always supposed to be the same A. So in most books, you find it written as A star E is equal to A, which is equal to E star A. This shouldn't confuse you. This is what they mean. So what does this mean? Let me give a practical example. So if you have, for instance, let's say 2, the inverse of 2 is 1 over 2. If you multiply a number with its inverse, with its multiplicative inverse, the multiplicative inverse of 2 is 1 over 2. So this is equal to 1. So this one is the one that we call the identity element. So every time you multiply every number with its multiplicative inverse, let's say we get 4, another example, and its multiplicative inverse, the answer is always supposed to be the identity element, which is just 1. So now, what happens if we multiply this identity element, which is in this case E, with its original element? So if we multiply 1 times 4, what are we going to get? Let's try that. So if we multiply 1 times 4, the answer will still be 4, which is making this statement to be true. We said if we multiply the identity element with the original element, the answer is supposed to be the original element. So the original element 4 times its identity element, the answer is still 4. Same applies to 2. If we multiply 2 times 1, 2 times 1, the answer is still 2. So when you multiply the identity element with its number, the answer is still supposed to give you that same number. All right, so okay, from this, we can now conclude to say, if you have, let's say, A as an element, then you find the operation between A and its identity element, the answer is always supposed to be that element. So this can also tell you one thing, to say any element that does not have an identity element does not have an inverse. What do I mean? For instance, if you remember very well, I said if you multiply 4 times its inverse, its multiplicative inverse, the answer is the identity element. So if you multiply 4 times its multiplicative inverse, the answer is an identity element. So when we say we don't have the inverse, it means that the identity element, if we say we don't have the identity element, we can simply say the inverse also does not exist. Yes. All right. So what am I trying to say? If you don't have the identity element, it means that you can't proceed to find the inverse. So the first step to finding the inverse of any binary operation is first to find its identity element. Okay, let's try to look at these examples. So we have A star B, which is A star B is equal to A plus B, then we have minus AB. For all values A, B, which are members of rational numbers. The identity element in respect of the operation is, so let us find the identity element of this expression. So remember we said A star E is supposed to give you A. So we are going to replace, okay, let me use X in this case so that you don't get confused, since the question is using A. So if we say X star E, the answer is supposed to be the same X. So now let us replace X star E in this expression. So X star E in this expression is going to be, while there is A, we put X. While there is B, I'm going to be putting E. So we have X E is equal to that X there. So what this means is that we are going to make E the subject of the formula. Why? Because that's the identity element which we are looking for. So we take this X to the other side of the equal sign. So we're going to remain with E minus X E, and this will be equal to X minus X. So this is now going to be, when we factorize this side, we're going to have E, which is common. Then we're going to have 1 minus X in the brackets like that. Then this will be equal to X minus X, that is 0. So we are going to have our identity element to be equal to, our identity element is going to be equal to E, which is equal to 0, everything divided by, this is 0, this is not B, is 0. 0 divided by, when we divide both sides by X minus, rather 1 minus X, let me do this so that you see what I'm doing clear. We have 1 minus X over 1 minus X. So when we divide everything by 1 minus X, we're going to have E being equal to 0 over 1 minus X. So the identity element for this expression is simply just 0. So this is the identity element. This is how you find the identity element. So let's look at the second part, which says, let X star B be equal to that for all A and B members of rational numbers. Then the inverse operation star is, so how do you find the inverse? Remember what I said? I said A star its inverse. The answer is supposed to be what? Let's look at this practical example. If we multiply 4 times its inverse, its multiplicative inverse, the answer is supposed to give us what? The identity element, which is E. So the identity element is 1 in this case. So A star its inverse, the answer is supposed to be E. So, and our E in this case is simply just 0, because when you look at this question and this question, they're the same. So I'm getting this same identity element. So when finding the inverse, the first step that you need to take is to find its identity element. Okay. So A star A inverse, we replace it in this expression. And then we equate it to E. So our E in this case is 0. So we're going to have, okay, let me use X. Anyway, it's fine. Hope you understand using A. So I'm going to say A plus, what is B? I'm going to be putting A inverse. And then I'm going to say minus A times A inverse. This is equal to my identity element, which is 0. So from here, I'm going to make A inverse the subject of the formula. So I'm going to take this A to the other side of the equal sign, so that this side I will just remain with A inverse minus A times A inverse. And this will be equal to 0 minus A. This will just be negative A, because this A is crossing the equal sign going this side. So here I'm going to factorize, the A inverse, so because that's what I want. I want to remain with A inverse. So I'm going to have 1 minus A in brackets, then equal to negative A. So my A inverse is just going to be equal to, when I divide 1 minus A here and 1 minus A this side, I'm going to have my A inverse is going to be equal to negative A over 1 minus A. So this is going to be my A inverse. It's as simple as that. So this is how you find the inverse of any binary operation. Let us look at the next one. So the next question we have is this one. For binary operation star on Z, which is the set of integers defined by A star B is equal to A plus B plus 1, then the identity element is, so finding the identity element is straightforward. We are always supposed to use this expression, which is A star E is equal to A. So I'm going to replace A star E in this expression. So A star E in this expression, according to this expression, will be A plus E plus 1. While there's A, I'm putting A, while there's B, I'm putting E. So we're saying this is supposed to be equal to A. So I'm going to have A plus E plus 1 is equal to A. So I'll take this A to the other side of the equal sign so that I remain with E plus 1 this side. So E plus 1 is going to be equal to A minus A. So this will be a 0. So I'm going to have E is equal to, E plus 1 is equal to 0. So I'll take this one to the other side. So the identity element will simply just be -1. So the identity element for this expression is simply just -1. All right, so let's quickly move on to the next question. Let me make one emphasis before we proceed. So since we have the identity element of this expression, it means that it's easier for us to find the inverse. But if we never had the identity element, we wouldn't have managed, or we would have concluded that there's no way we can find the inverse. Okay, so let's quickly move on to the next question. So we have this question here, which says A star B is equal to AB over 2 for A, B members of positive rational numbers. The inverse of 8 is, so the first thing that we need to do is to find the inverse of this expression. After finding the inverse, then we're going to replace 8 while there's, we're going to have A. So let's quickly do that. So the first step when finding the inverse is to first find the identity element. So we first say A star E is equal to A. So while there's A, we're going to put A, and then while there's B, I'm going to be putting E. And then I'll equate everything to A. So I'm going to have A star E. This will just be, while there's A, I'm putting A. While there's B, I'm putting E. Then everything is divided by 2. This one is supposed to be equated to A. When I do the cross multiplication there, I'm going to have A, E is equal to 2A. Then when I divide by A this side, even this side by A, my E, which is the identity element, will simply just remain as 2. So my identity element will remain as 2. So the identity element is just going to be 2. So now that I've found the identity element, it's easier for me to now find the inverse. Remember what I said about the inverse? A star its inverse. When you multiply, when you find the operation between any element A with its inverse, the answer is always supposed to be E. So when you multiply 4 times 1 over 4, which is its inverse, the answer is the identity element, which is 1. This is what this means. This is what this means, yeah. So we are going to say A star A inverse. So I'm going to put A and A inverse in this expression. So I'm going to have A times A inverse, then everything divided by 2. The answer is supposed to be my identity element, which is 2. So here it's just a matter of making A inverse the subject of the formula. So I'm going to cross multiply. I'm going to have A times A inverse is equal to 4. So when I divide everything by A, the answer will be A inverse is equal to 4 over A. So my inverse of, the inverse of this binary operation here is 4 over A. So now to find the inverse of 8, the answer will simply just be, so we say A inverse, or we say the inverse of 8, we say 8 inverse is now going to be equal to, because we know that the expression for A inverse is simply just 4 over A. So 8 inverse is simply just going to be 4 over 8, which can be simplified as 1 over 2. So this is not the exact multiplicative inverse of 8, no. This is the inverse according to this operation here. So this is the inverse of 8 according to that operation. Let's quickly move on to question 37. Let A star B be equal to A plus B plus 10 for all values of A and B are members of natural numbers. Then the identity element for star is, let's find the identity element for this. Remember, the formula for identity element is A star E is equal to A. So we find A star E according to this expression. So this is just going to be A plus E plus 10 is equal to A. So when you take this A to the other side of the equal sign, we're going to have E plus 10 is equal to A minus A, which is just going to be a 0. So we say E plus 10 is equal to 0. So to find the identity element for E, we take this 10 to the other side as well. Hence, we remain with E is equal to negative 10. So this is the identity element for this expression. And since it has the identity element, this implies that it also has the inverse. Let's quickly move on to the next question. So this is the last question that we have. So this question says, let A be a non-empty set. Let star be a binary operation on P of A. The power set of A defined by X star Y is equal to X union Y for all X and Y are members of the power set of A. Find the identity element of the power set of A with respect to star. So this one is also straightforward. We know to say X star Y is given by the operation X union Y. So to find the identity element, we follow the same procedure. We say X star E, which is the identity element, is supposed to give us X. So in this case, the operation is union. So we're going to say X union E. This one is supposed to give us X. So now, if X union E is able to give us X, this implies that E is a subset. So this implies that E is a subset of, so this implies that E is a subset of what? E is a subset of X. So now, if E is a subset of X, they're asking us to find the identity element of this expression, the identity element of the power set of A. So if E is a subset of X, and we know that X union E is equal to X, the one of the expression that we can say can give you this solution is when you have, let's say for instance, A as an element in the first set, and then you say union an empty set. This is when you can have A as the answer. So when you say A union empty set, the answer should always be A. So in this case, we can conclude that for this for this X to be the answer after finding the union between X and the identity element can be therefore concluded to be an empty set. Can also be concluded to be an empty set. Yeah, so in short, the identity element of this power set of A is simply just an empty set. So now there is this other part which says show that phi, which is an empty set, is a member of the power set of A. So a power set of A is simply just a set that contains the subsets of A. So the power set of A is the only invertible element of the power set of A. So what do they mean by invertible? So invertible element simply means it's the only element which has an inverse in the element of the power set of in the power set of A. Okay, let's see what we do when you've been given such a question. So this one is straightforward. How do we do it? So we start first by looking at what we have here. We know that E is an empty set, And then we said for the inverse, according to our discussion, for the inverse, we know to say, for the inverse, for when finding the inverse, we know to say, if you have any element A, star its inverse. So A star A inverse, A star A inverse, the answer is always supposed to be the identity element. So in this case, we have X, we're using X. So we're going to say X star, the inverse of X in this case is simply just the empty set. So X star empty set, the answer is the identity, rather, I didn't say that, sorry, it's not supposed to be the empty set here. I was supposed to say X star, the inverse of A. So I'm going to say X star, the inverse of A, is supposed to give me an empty set as the identity element. So here we can now say, we can replace this X star inverse of A in this expression. So I'm going to say X union A inverse, oh, not really A inverse, but X inverse. Since I'm using inverse, even here, let me just replace back the E. Yeah, so we say X star X inverse, the answer should give me that is the identity element, which is in this case is an empty set. Yeah, so in this case it's an empty set. So how do I conclude this expression now? They are saying I should show that phi is a member of the power set of A. Okay. I mean, I should show that phi is equal to, is a member of that and is the only invertible element. So when you look at this, we have X union X inverse, and the answer is an empty set. So what we can do here is that, I mean, what we can say here is that if you have X union its inverse, if you have X union its inverse, then this is giving you an empty set. So what you're going to do is simply just wait a bit, I'm coming, let me just finish doing this. Let me just do this quickly. Okay, I'm done. All right, so in most cases, when you have two elements, if you have A and then you say A union A, then if the answer is an empty set, usually you discover that both sets are empty sets, because there's no way you can have A union empty set to give you an empty set. It doesn't work like that. When you find the union set between any element with its empty set, the answer is always that element. So this one can't exist. So for this condition here to be possible, it means that both sets X and X inverse are both elements, both sets X and X inverse are what? Are empty sets. So in this case, this is just the same as us saying, and this is an empty set, this is also an empty set. So X inverse is an empty set, and what's this? X is also an empty set for us to get this empty set as the answer. So this implies that the only element that is invertible in this expression is an empty set. That's all. I mean, this element here, which is phi. Yeah, so the only element that is invertible in this power set of A is simply just phi. Why? Because you can't, any element that you're going to put here will not give you an empty set as the identity element. Let's say if in the set maybe we had one, if we say one union its inverse, let's say for instance, okay, let me use two. If you have two union its inverse, which is 1/2. Okay, not really this 1/2. Okay, let me do it this way for you to understand. Okay, let's say if you have, let's say you have any element x, I'll just use symbols. Any element x union its inverse. Like an example which I gave here, there's no probability of you, in short, there's no probability of finding an empty set after finding the operation between any element and an empty set there. So any element in an empty set, the answer is supposed to be that same element. So the only way you can have the empty set as the answer after finding the union between two sets is when you have both sets being empty sets. That's the only time you can have the empty set as the answer. So in other words, this is the only invertible element in this expression. I mean, in this operation. All right, so thank you very much for watching this tutorial session. See you in the next tutorial session that we're going to have. My name is Harmtedy, and then if you have not yet subscribed to the channel, make sure that you do so by clicking the subscription button. See you in the next video. Shalom, shalom. My name is Harmtedy.